Abyaz, am I audible to you?
Yes, ma'am.
Okay. So in the last class, we stopped at this induction point. I think in the last moment of the class, your network was not well. Now is your network better?
Yes, ma'am.
Okay.
My network
So,
is not good, ma'am.
yeah,
Like in 2 days, I'll go to Saudi. So that time network will be good. So I'll try to on my video.
when will you go?
In 2 days, day after tomorrow.
Okay. So you just came for your vacations over here.
No, ma'am. I study here only, in India.
Okay, you studied in Kerala only.
Yes, ma'am.
Okay, so you're going to Saudi for some time.
Yes.
Okay, there your network will be better.
Yes, ma'am.
Okay. So see, Abyaz, what all things we saw in the last class? Three methods we have. Have you revised?
Ma'am, I have doubt in some parts.
Tell me.
Like in this glass in like the last topic you took, right? I was like disconnected. So in that, I wasn't focused.
This one.
Like in the last topic before the class ended, the last
Yeah,
class.
this is what it was, charging by induction. I think you got disconnected. That's why.
Yes, ma'am.
Uh, and Abyaz, I have not received your homeworks. You're not sharing the homework. You're not doing them.
Ma'am, actually, in that it's showing no, it's showing some topics of the. It's showing the topics, but I don't know what to do in that. Like to do questions or it's not mentioned.
No, is that online Learnivio's portal better now? Whatever you were not able to log in and all.
Man, now I can log in. Before I had the issue.
Now
Now I
you
can.
can log in. So
Yes,
are
ma'am.
you getting the access to the homework?
Yes, ma'am. And also, I can't like upload the files in there.
Okay,
Yeah.
Abhay, in such a case, do one thing. When you are not able to upload, just send the PDF on WhatsApp on the Learnivio's
Okay.
number. Just send it on the WhatsApp. They'll share
Okay.
it to me, so I'll check it in that way. Because this
Okay.
will delay. Right now, these are very small topics, so it's okay. We could have just adjusted. But after this, in today's class only, we'll start with numericals, calculations based questions. So
Yes, ma'am.
we need discussion. So for that, you need to upload the homework so that at least I know how much you have, how much you are able to know.
Ma'am, homework means like it's showing charging by induction. So what should I submit? I don't understand.
Yeah. That is only after every class you get an assignment of 2 to 3 questions that I'm referring to as homework.
Like in that app, questions will be shown.
You have doubts in those questions.
No, actually, you said like they will give questions, but here there's no questions. They just saying to submit.
Okay, you are not able to see the questions.
Yes, ma'am. It's only written like charging by induction. That's it. Nothing is shown. That's
and
why I can submit.
and question part is not visible.
No, ma'am. Just charging by induction and below it says submit. That's it.
Okay, you are just seeing, you are able to see the topic, the heading, but the questions are not visible.
Yes, ma'am. That's the problem.
Okay. I'll just tell them to share the PDF to you also on WhatsApp once, because
Okay.
until the time this repairing and all on site is done, because we, let's not waste our time, no. So at least on by the medium of WhatsApp only, let us just at least get these questions clarified. I'll share the PDF on WhatsApp at least, and I'll tell the team also. They'll just check it once, the Learnivio's portal of yours account. I'll just tell them to re-upload it. This will be done. In the last question, let's discuss what you missed that time. See, a question came. Charging till before this, I think you were able to understand. Till earthing, you understood.
Yes, ma'am. Only after that I couldn't.
After that, you left. Yeah. See, there was a question in your NCRT. This is that only. It says that a sphere is present. This sphere is put on an insulating stand. So insulating stand, as discussed, this insulating stand just helps to prevent the loss of electrons to the earth. So this sphere is put. The question says, make this sphere completely positively charged. Right now, when equal amount of positive charges and negative charges are present, we say this body is neutral. Means no excess of charge is present, right?
Yes, yes, ma'am.
Now we want to make this have an excess charge of positivity, means positively charged sphere. So now we are going to apply the charging by induction process here. What we do here, we bring up a glass rod which is negatively charged. Why? Because we want to make this positively charged. So what we'll do, we'll bring such kinds of charges that will attract these positive charge. And the only charges that can attract the positively charge is the negative charge. So
Yes.
that's why we are bringing this glass rod with negative charges. Now this is having negative charge. Now a sphere is present. What will it do? It will attract all the positive charge towards this end,
Yes, ma'am.
and slowly negative charges will develop here. So till here we have separated the charges, but this is not what the question is saying. Question is saying you have to make the charges completely positively charged. This is not temporary electrification that you just need to separate the charges. So what we do, we apply the earthing, means we just connect it with a wire and connect it to the surface of earth. So what happens? As discussed in the previous class, if you remember, electrons travel through the wire to the surface of Earth. Remember?
Yes, ma'am.
So what will happen? I am keeping the glass rod intact. Right now they are separated. But as soon as I'll remove the rod, they will mix up and they'll become back to this neutral state again. One positive, one negative, they'll recombine and all. So what I'm doing, till the time I'm holding this glass rod, the positive charges are getting attracted to this negative glass rod. But these negative electrons were creating trouble for me. So I just connected with the wire and I earthed them. So what happened? All the negative charges went away. As the negative charges went away, I disconnected it from the surface of Earth. Now only positive charges are present with the glass rod. Now, even if I remove the glass rod, there aren't any negative charges in the sphere now left to make this sphere back to neutral. So I can easily now freely remove this glass rod. What will happen? These negative charges, these positive charges which were accumulated here, they will spread, and this is how we obtain a positively charged sphere. Got it?
Yeah. Yes.
Abyaz, tell me one thing. Did you write it?
On this part,
Hmm?
no, ma'am. Like I was
Okay.
completely.
Okay. Okay. Then you copy down this.
Okay. Hello, ma'am. Am I audible?
Yes, you are. You there? You've written?
Uh, yes, ma'am. Finished. I got
Yeah,
this.
you got disconnected again. Okay, let's start with the properties of charges. Now, methods of charging are done. Revise them properly. The three methods of charging, amongst them, charging by conduction is also very important, and this charging by induction. Charging by conduction will be used in this chapter only. Charging by induction will be used in the next chapter. So revise them properly. Let's start with what are the properties of the charges. See, first I told you, if you remember, charges are scalar quantities. Remember scalar?
Yes, ma'am. I remember.
So here what happens if I have, let's say, if I have some charges plus 2 coulomb, minus 3 coulomb, plus 3 coulomb, like this. So all the charges, since they are scalar quantities, we can simply add all these charges. Additive nature of charges means you can simply add all the charges. Like if I want to calculate what's the net charge, this will be plus 2 coulomb minus 3 coulomb plus 3 coulomb, like this. So the net charge will be plus 2 coulomb. Like I can simply add the charges, subtract the charges, that's it. This is the first property. Second property is conservation of charges, which we have been studying. That charges can neither be created nor be destroyed. They just get transferred from one body to another body. If one body is present, this is second body present, charges will just be transferred. And now we know which kind of charge gets transferred. Abyaz, can you tell me, is it protons or electrons which get transferred?
Electrons.
Electrons, yes. So electrons get transferred. So when from wherever they get transferred, they make the body as positive. From where they are entering, they make the body as negative. And this mechanism we have seen in detail why this happens. So this is the same property. Third property is invariance of charge. Invariance of charge means charges do not depend on speed. See, this is how they are differentiated from masses. Masses are what? See, there are two differences, major differences between charge and mass. Mass can be zero, mass can be positive. Masses can never be negative. But charges are those kind of intrinsic properties that can be positive also, negative also, zero also. That this is one difference between a charge and a mass.
Okay.
Second difference is that there is a formula, if I don't know if you remember from your class 11th, M is equal to mass of a body is equal to the resting mass divided by under root 1 minus V square by C square. This is there in your 11th class in CRT. So see, masses have this dependency. But why? Because the objects that are normally traveling, they are having some velocities. The velocities are comparable. They are very small. Like if a body is moving, it will move with some velocity 5 meter per second, 8 meter per second, like this. So velocity will be less. But problem with charges is that this velocity is comparable with the speed of light. What's the speed of light? 3 into
It was
10 to
like
the power 8
one.
meter per second. Okay, 3 into
Okay.
10 to the
Okay.
power 8 meter per second. So charges can travel at this rate because you see when you switch on the circuit, immediately the light bulb glows. So light travels fast, right? All the charges travel fast. But in case of masses, we have seen in your laws of motion of class 11, masses do not have such a high speed. So that's why charges do not depend on speed, but masses have this relation and they depend on speed. So this is the third property. Till here, the three properties are clear.
Yes, ma'am. It's clear.
Okay, so do one thing, write it till here because this quantization is a little lengthy. Then I'll discuss.
Okay.
First,
Okay.
write. So see till here you've written. Let's start. This is the fourth property, quantization of charges. If you remember, can you tell me what is the amount of charge held by one single electron? We discussed in our first class. One electron, how much charge one electron is holding?
1 electron.
Yes, charge, amount of charge. I told you there's certain amount of charge, which is called as the electronic charge.
Ma'am, I think it's 1.602 into 10 raised to minus 90.
1.6 into 10 to the power minus 19 coulomb. This is the
Oh,
amount of charge that is held by one electron. So remember it. Now, you tell me, if I take two such electrons, it will be 2 times this, right? One electron is
yes.
having this charge, 2 will have this. So it will be 2 into this number, that is 1.6 into 10 to the power minus 19. Like this will be 3.2 into 10 to the power minus 19
Yes, ma'am.
coulomb. Like if I then take 3 electrons, so these will be 3 times this value, 1.6 into 10 to the power minus 19. I take 4 electrons because 1 is having this value. So 2 will have double, 3 will, 4 will, 5 will, 6 will. These will have such values, that is 4 into 1.6 into 10 to the power minus 19. Like this, if I keep on increasing the charges and it becomes n times e. So it means this will be n into this 1.6 into 10 to the power minus 19, this value. So these will be, so basically what can we get? What is the formula? When you have to calculate the charge on any electron, whenever you have to calculate the charge or charge on any particle you have to calculate, you have the number of electrons available. So what is our formula? If you see, this charge can be calculated as the total charge that we were calculating is rather n times this E value. Yes. E means this E Abyaz, this means 1.6 into 10 to the power minus 19. Yeah, Abyaz, can you now hear? Is it better? Yes, Abyaz, you're not audible.
Hello, ma'am. Can you
Yeah, yeah.
can you
Okay. So see, I was saying that
continue?
if we have one electron, which is equal to 1.6 into 10 to the power minus 19 of coulomb, I have n number of electrons. So I can write this, the total charge as n times E. Do you agree?
Any.
Yes. So this is the formula. This is the first formula of your class 12. That is charge. Q means the charge. N means the number of electrons, while E is the electronic charge. This value you have to remember because in the exam this won't be mentioned. This is the electronic charge, which is equal to 1.6 into 10 to the power minus 19 coulomb. This is the electronic charge. So what is the quantization of charge? This can come separately also to write. Quantization of charges basically means that charges
Any.
are integral multiple of electronic charge, means that is 1.6 into 10 to the power minus 19. They are integral multiple, means they are n times this value of. Is it clear till here?
Yes, ma'am. It's clear.
Okay. Write down this page also, then we'll start with the questions from this. Questions have come from this. From the past 2 years, the questions have not come, but before 2 years, questions have come from this topic.
Okay, ma'am.
Okay, Abyaz. Now let's see the questions. See, this is the first question. This says calculate number of electrons corresponding to 1 coulomb. What's the charge given, Abyaz, here?
Ma'am, 1 coulomb.
1, exactly. So here charge given is 1 coulomb. Number of electrons we have to calculate. So which formula should we use?
Hello, ma'am.
Which one?
Ma'am, what was the question?
See, you have to calculate number of electrons, means number is missing. Like we were discussing, no, 1 electron, 2 electrons, 3 electrons. So the number is missing, that you have to find out. Q, charge is given as 1 coulomb. N is missing.
Charge is 1C.
Which formula?
Formula means like what we should find N.
See, formula means in order to find out the value of number of electrons. How can I get? You just think, how should you proceed? I'll tell you the answer. I just want you to think once. Just think, how should we get the number of electrons? You have the charge as 1C. 1. Charge is
So
given 1 coulomb.
we should find with the charge
Charge is given to
of
us.
1 electron.
Yeah. N, number of electrons. You've
Yes.
just written a formula. See in your notes.
Yes, ma'am. I know the formula. It's 1.6 into 10 raised to minus 19.
Yes? Can you repeat?
1.6 into 10 raised to minus 19.
That is the electronic charge, right? 1.6 into 10 to the power minus 19 coulomb is the electronic charge.
Yes.
So how can I connect these three? Q, N, and E.
So
A
I
formula you
think we
have
should
written. Just check. This
calculate
one. Look,
one.
this.
Yeah, Q equal to any.
Yes, Q is equal to NE. We will use this, okay? Because we have the charge. N is missing and E has to be calculated. So charge is 1 given, 1 coulomb. Number of electrons are missing. What is E? 1.6 into 10 to the power minus 9. So N will become 1 divided by this.
1 equal
Yes, 1 by E. That
to.
is this.
It's
So
equal
when
to
you
1.
will solve, this will come out to be 6.25 into 10 to the power 18 electrons. Is it clear?
Yes, ma'am. It's clear now.
Okay, write it.
Yes, ma'am. Finished.
Okay. One more question before we discuss any of these questions. Yes, let us discuss this one first. Oh, before this, one more question, Abyaz. Okay, I am giving you a question. This says, if an object has 10 to the power 19 electrons present, You have to calculate the total charge. Can you now help me with this question? An object has 10 to the power 19 electrons. We want to find out the net charge. How should we proceed now?
I think first we should take the charge of electron.
Yeah, that we have to calculate, right? Charge is missing. Total charge means Q is missing. Now, what is the formula? Repeat the formula.
Q is equal to Ne.
Exactly. Formula is, so I hope by now you will remember also this. Q is equal to
Yes.
Ne. This is the formula. Is Q given to us?
No, ma'am. Q is not
We
given.
have to calculate. Is N given to us? Number of electrons?
Yes, ma'am. 10
10
raised
to
to
the power 19. Do we know the value of E?
no, ma'am.
Electronic charge, we know. E, you have written in the quantization. What is the value of E?
Oh, sorry, ma'am. 1.6 into 10.
Yes, 1.6 into 10 to the power minus 19. So this value you have to remember, Abyaz. Otherwise, you will not be able to solve any question. So see, Q will be equal to, now N is 10 to the power 19 into electronic charge is 1.6 into 10 to the power minus 19. This gets cancelled. Charge is 1.6 coulomb. Understood?
Yes, ma'am.
Okay, write this, then we'll see some more questions.
Ma'am, finished.
Okay, let's see some more questions now. Let us see this question first. So this came in your board examination. This says that in an experiment, 3 microscopic latex spheres are spread into chambers and become charged with plus 3e. Basically, 3 spheres are present. One is having the charge plus 3e. Second is having the charge plus 5e. And this is having the charge minus 3e. These are the spheres. Then they are brought in contact, all the 3 spheres, and then they are separated. We have to calculate the final charges. So like what will be the charges on these? Suppose this is this first sphere, this is the second sphere, this is the third sphere. This is A, B, C. This is the same sphere A, B, C. So this is before. Before means before they are connected. So, okay, if they just come in contact and they get separated, which method of charging is it?
Yes, ma'am. Which one?
if the spheres are coming in contact and they are getting separated. Which method is this? We did 3 methods: friction, conduction, induction.
I think it's conduction.
Conduction. See, when the contact is made, no, when the objects are rubbed, that is friction. If they are brought in contact, that is conduction. And induction was that one, glass rod one. Okay, so yes, this whole process is charging by induction. This is 6. Okay. Now see, these are the 4 options. It is saying once they are brought closer to each other and it is separated, what are the possible charges? So see, how will we do is, what is the total charge before they are colliding? Total charge here.
Total charge it is plus 3 and plus 5e and minus 3e.
Yes, 5e. See, initially what will happen? Plus 3e
Plus
plus
5e
5e minus 3. Minus 3 minus 3 gets means
minus
initial
3e.
charges plus 5e. So, Abyaz, do you think the final charge will be different? Initial and final. They are always equal because of conservation of charges.
Yes,
Uh, yes, charges, whatever are the initial charges will be the final charges. So let's see if this is our answer. Let's check whether this is our answer or not. If this is our answer, their total should remain plus 5e only because charges are not changing. Total charge won't change. Plus 5e minus 4e. Is it giving you 5e? 5e plus 5e minus 4e. What's the net?
I think it's, I mean, it's not the answer.
Add it, just add it. Just add them.
Then it will be plus 80, then
Plus,
plus 80,
not
right?
8, 6. See, 5 plus 5 is 10. 10e minus 4e, 6e.
Okay.
So we are getting 6e. Is 6e and 5e equal? No. Means this is
No,
not our
ma'am.
answer. Let's check the next part. 6e plus 6e minus 7e. 12e minus 7e, 5e. So it means yes, this is the right
This is
answer.
equal.
Okay, so this is how you have to solve this question.
Yes.
Please write down this.
Okay.
Okay, let's start the next question. This we have completed this one. See, this says an object has charge 1 coulomb. This gains 5 into 10 to the power 18 electrons. Means an object is present. This is having charge 1 coulomb already. 1 is there already. Now it is having
How many charge? One charge.
1 coulomb. Okay. 1 is already present. It is saying it gains 5 into 10 to the power 18 electrons. It is asking what will be the net charge on the object now. See, Abyaz, if I tell you that some amount of charge has entered, then you can calculate the net charge easily. But problem in this question is that it didn't give you the charge directly. It told you that these many electrons are entering. So what we have to do first, for these number of electrons, we have to calculate the charge. What will be the charge due to these electrons? So one formula we have done, if we know the number of electrons, repeat the formula. What is it?
Q equal to NE.
Ne. We have to calculate the charge. What is N?
N is Q is 1.
No, not this Q. Q is not Q. See, I am repeating this. You have not understood it. This question said that 1 coulomb is already present. Forget about it. Some new electrons, these many electrons have entered. They are coming within this. Okay, these many electrons are entering here. Now, if these many electrons are coming, the net charge will be disturbed. If 1 coulomb is present, so many electrons are coming. Will it still be 1 coulomb or it will change? Yes,
It will change.
it will change, right? So how will it change? How much charge has entered? We don't know the charge. The question didn't tell you the charge. But
Yes.
what did the question tell? It told you that it gave you a hint by giving the number of electrons. Okay.
Yes, ma'am.
Now, can we calculate the charge for these many electrons? Only these many.
Yes, we can calculate.
We can calculate. The charge will be equal to N times E. Charge we have to calculate. What is N? Number of electrons?
N is
It is
N,
N is
5 into 8, 5 into 10 raised
yes,
to 18.
5 into 10 to the power 18. These many electrons. And what's E?
Yes, ma'am.
E will be
It is 1.6 into 10 raised to minus
yes,
19.
1.6 into 10 to the power minus 19. So when you will calculate, this comes out, because this is negative, it is for electrons now. So we are taking minus 1.6. So this will come out to be minus 0.8 coulomb. Is it clear till here? You've understood?
Yes, ma'am. It's clear.
Okay. Now see, Abyaz. If now we can say minus 0.8 coulomb has entered. Now, instead of electrons, we have calculated the charge. Can we now say that 1 coulomb was already present? Now, minus 0.8 coulomb has entered. Can we say that?
Yes, ma'am.
Question said 1 coulomb is already present. These many electrons came. We didn't know the charge, so we calculated the charge. Now we can say, okay, you are saying these many electrons came. We are saying minus 0.8 coulomb came. Now it is asking what will be the net charge now. So see, the net charge will be 1 coulomb was already present and minus 0.8 has come. So it becomes 0.2.
Yes, ma'am.
Clear?
So 1 coulomb plus minus 0.
Plus minus 0.8. Exactly. Okay. This also came in the board
Okay.
exam. Please write this question. Okay, okay, Abyaz. So this completes with the class duration also. So in the next class now, I'll continue. See, one question I'll
Nice,
discuss
nice.
from this topic. So as a revision from NCRT, and then I'll start with the next topic, that is Coulomb's law. So meanwhile, please revise this whole concept of electric charge, okay?
Yes, ma'am.
And do the
And
homework
can you
also.
send the WhatsApp PDF?
You can share the homework on WhatsApp. I'll tell them to share it on WhatsApp to you. That can be done so that at least in the next class we'll have a discussion. Okay then,
It's like,
Abyaz. Okay then.
can you
Thank
share
you.
in WhatsApp?
Yeah.
Like, can you share in WhatsApp in the app? I can't receive.
You have the Learnivio's meeting ID number from where you get the
Yes,
meeting
ma'am.
ID. Yeah,
Yeah, I
share it
have.
there.